Alright, so this will be a video on the different graph trends of a position time graph and a velocity time graph. Now, this is very essential before you proceed with a problem solving in terms of the different quantities such as velocity, acceleration, and displacement, is to first see the different trends in a specific graph, because these different trends can actually give you already the answer, not the numerical value. However, you can check kung yung graphical agrees with the numerical value that you'll be getting, okay, or solving. Now, for our objectives, we'll be differentiating a distance time graph and a velocity time graph, and then interpret different graph trends and their different implications. Now, with that, we're going to use a PHET simulation, which is seen. You can actually download this PHET simulation. The title, I think, is Moving Man. You can use this one because actually gagamitin pala talaga natin to for the laboratory activity. Okay, sige, let me open para makita natin siya. Okay, so this is like the sample of the moving man. You can see the man can be moved from left to right, and as I move the man from left to right, you can observe that there's movement in terms of the position, the velocity, and the acceleration, which are the different descriptors of motion, or the different quantities that describe a specific motion. You can observe that if I move yung position niya, velocity niya moves, even the acceleration. Since I'm using my mouse, and then I'm not moving it at a constant speed, that's why yung acceleration niya and velocity, nagmo-move siya ng parang rapidly. It doesn't really have a specific constant na movement. Okay? So, yan. Mamaya na tayo dyan. Balikan na lang natin siya later on. Let me reset this one. Right. Sige. Going back to the presentation, so let's first begin with the distance time graph, okay, or the position time graph. Commonly called siya as a position time graph because mas specific yung position time graph compared with the distance time graph and a displacement time graph. So yung iba, they call it position time graph, so it's safer to say na ganun siya. Pero sa atin, DT graph is a distance time graph. Now, for the distance time graph, we're going to use the moving man for the simulation. You have here different questions. What happens to the graph as the man moves to the right from 0 mark? What happens to the graph if after moving we stop the man for rest? And then what happens to the graph as the man moves to the left from the 0 mark? So these are different questions that we're going to answer using the simulation. Now, in the distance time graph, you know that if you have a graph, you have your x-axis and your y-axis. In terms of DT graph, the time is the x-axis while the distance is your y-axis. So please not forget that, because the labels are very essential in terms of finding the slope and then finding the finding the exact value, or finding what is really the slope of a distance time graph. Okay, this will make sense later on and on the future videos that we have. Okay, sige, let's open the simulation again. So you can see here, so under charts, we're going to open this. You can see na meron tayong tatlong graph: position, velocity, and acceleration. But we're going first to hide the velocity and the acceleration kasi our focus is the position. Okay, if you remember the first question, sabi daw, if this is your x-axis and this is your y-axis, okay, you can observe my mouse na lang pakitingnan, and then you have here your graph. So, lahat ng sa taas ay positive, nandito sa baba ay negative, and then nandito sa the right side is positive. So, what happens to the graph daw if we move the man to the right? Okay, let's move the man to the right. Observe the graph. Okay. Sige, ipopause lang natin to. Okay, pause. So, you can observe that this value right here, the graph is rising from left to right. So, when you move the man from the 0 mark going to the right, you can observe that there's a rising slope in terms of the graph. So, it's rising from left to right. The next question that we have, if we go back to the next question, ang sabi is, what happens to the graph if after moving, we stop the man for rest? So, ipapatigil lang daw natin yung man. So, let's play this. Ayan. So, you can see that the graph is a horizontal line. So, again, let's just review. When we move the man from left to going to the right from the 0 mark, so yan, nakastop siya, biglang nag-rise siya, rising from left to right, or increasing yung value niya. And then, from this value right here, nag-stop tayo. Okay? The next question that we have is what happens to the man if we move it going to the left or going back to the 0 mark? Okay. Going back to the 0 mark. Hanggang 0 lang. Ayan. And then, stop natin siya. So, you can see that there's an implication in terms of the movement and the graph that we have right now. If we see in the position time graph that the graph is rising, it means that there's a movement, right? If there's a movement or there's a motion, but if it's rising, you're going to the positive direction, right? Now, next, nung tig-stop natin yung man, you can observe that there's a horizontal line. There's no slope, di ba? Kasi nga, horizontal line lang siya. If it's a horizontal line, the slope is 0, ibig sabihin there's no motion in general or the man is not moving. Now, lastly, in terms of our interpretation, what if we move the man going to the left? Ang nangyari sa kanya is the graph is falling from left to right. Or basically, it's going backwards or going to the opposite direction until such time na nag-rest na naman siya. Sige, let's clear this para makita ninyo. So, I'm going to try it again para ma-observe natin. So, rising kasi nag-go siya to the left. Falling, nag-go siya to the, right pala kanina, left. Ayan. Stop natin. Straight line. Rise again. Stop natin. Ayan. And then, go back again. Sir, bakit may negative? Di ba wala naman negative na position? In this case, the negative sign just tells us that it's going to the opposite direction. Okay? So, I hope it's clear in terms of the implications that we have right now na pag may nakita kang graph going to, if you see a graph rising from left to right, it's moving forward. Pag nag-stop ka, it's a flat line or a horizontal line. If you go to the left, it's falling. Okay? Sir, bakit tiko siya or ganyan, hindi siya as straight as possible? Kasi nga, I'm using, what do you call this? I'm using my mouse as the indicator of their movement. So, hindi masyadong constant yung velocity na lumalabas sa kanya or yung movement niya. Okay? So, at this moment, I hope this is clear in terms of their implication. Pag nakakita tayo ng graph na ganito, no movement, moving forward, no movement, moving backward, stop, no movement. Okay? Sige. Alright. Let's check the PowerPoint. Baka meron ako nakalimutan. Alright. Next, since we have mentioned already the implication, what does a horizontal line indicator imply? What does a graph rising from left to right imply? What does a graph falling from left to right imply? And what does the slope mean? So we know that pag horizontal line, no movement, rising from left to right, moving forward, falling from left to right, moving backward, and then yung slope, based on the reading material, is the velocity. Now we're going to look into the different types of motion that we have, which is zero velocity, and constant acceleration. So, babalik tayo dito sa graph natin. Okay, so i-clear ko lang to. Pakita ko yung value ng velocity. Okay, what if we have a constant velocity? Do not mind this graph first. Okay, ang ima-mind natin ay position time graph. Okay, let's reset everything muna. Let's hide the acceleration. Maglalagay ako ng 2 meters per second. Okay, which is a constant value of 2 meters per second. Sige, 2 meters per second. And then I'm going to click play. Observe the graph that you are having right now. Okay, let's stop him for a while. So you can see that in terms of, do not look at the red line first ha, para hindi tayo malito. Okay, again, as I've mentioned, if you have a graph which is a straight line in this case or rising from left to right, there is a specific movement which is going forward. However, this moving forward in terms of a position time graph can be called as a constant velocity. Okay, the movement that you have, if you have this one, is a constant velocity. So, gawin nating 0 para walang movement. Tingnan natin yung mangyayari sa graph niya. Okay. So, when I moved it, when I change the velocity to 0, you can observe that it's a straight line because as you have mentioned, a straight line or horizontal line, sorry, baka maribong ka mo, a horizontal line indicates that there is no movement at all. Okay, or there is a zero velocity or there is, the person is at rest right now. Okay, again, wag nating titingnan muna tong velocity dito kasi mariribong ka mo kasi bakit may nagganyan. Okay, next, let's try to change this to negative 2. Okay, negative 2. And then observe the movement of the man as well as the blue line. Okay? Let's play. Ayan. So you can observe again that, alright, the graph is falling from left to right. The movement is going to the left kasi going to the opposite direction, and the velocity is constant, which is -2. Okay, so what we can say here in terms of implications, in terms of graphical trends, in terms of understanding what it looks like in terms of graph, ang rising from left to right, which is this one, instead of sabihin nating moving to the right or to the positive direction, is considered or called to be constant velocity. So this indicates a constant velocity. Bakit siya sinabing constant velocity? You'll see this in the problem solving, but at each point po, pag mineasure mo yung slope dyan, it's just the same. At kung yung slope niya is 1, ibig sabihin lahat dyan at any time frame will have a 1 value of slope, a value of 1 as slope. And here, this is a zero velocity or no movement at all. This one is a constant velocity, but it's a negative direction. Alright? So hopefully you understand now in terms of understanding. You can see now that the implication of the position time graph. So a rising from left to right instead of course you can still say it as moving forward. This is constant velocity. This is zero velocity or no movement at all, while this one is falling from left to right or a constant velocity pa rin in the opposite direction. Okay? So you can see how they're related with each other. Sir, bakit mo ginagalaw yung velocity? Because technically po, the slope of a position time graph is your velocity. Okay? So you can see, ang slope nito, ibig sabihin, 2 meter per second. Ito naman, ang slope nito ay 0. Ito naman, nakita nyo, ang slope nito ay negative 2 meter per second. Sir, bakit may ganito sa graph na to? It actually just means na by that time, yan yung biglaan na change ko bigla yung value na from 2 naging 0. Kaya po, yung graph niya, i-interpret niya as like an instant na movement. Okay? Pero in real life, daiman nangyayari na from 2 to 0, it of course decreases as time goes by. Okay? So, hindi siya pwedeng biglaan lang ng ganon. Okay? Let's go back to the PowerPoint presentation. Alright. In terms of the simulation, as I've mentioned, we can say about the motion of the objects represented below is that for this one, for letter A horizontal line shows that there's no movement or a zero velocity. A rising from left to right shows that it is increasing or there's movement going forward or is a constant velocity. Ito naman, falling naman na ito. This is constant velocity in the opposite direction. Okay? Now, again, as I mentioned, A, B, C, we've mentioned this one. For D, E, and F, D and E, we'll discuss this later on. Plus, please just observe the itsura or how it looks like sa graph na to. You can see na parang exponential yung growth niya. Same with this one, may pagka-exponential to, pero hindi growth yung term niya. And in this one, it's just the same with constant velocity yung F, pero it's a little bit slower compared to B, okay? Because this line is steeper. We'll be discussing this later on, pero pag steeper ang line, ibig sabihin, mas mabilis siya. Ipakita ko po ha, para ma-interpret natin siya. Sige, let's just clear this one. Tingnan nyo po ha, bibilisan natin to. So, mas mabilis, and then bagalan natin ng konti. Ayan. So, you can observe this graph from this graph right here. This line segment dito, if I'm going to cut this, kasi hindi natin makakat. We just observe the mouse. Itong part na to is steeper compared with this part because this one is faster compared with this one. Okay, so you can try this later on. You can try to experiment. And you can see as well, yung velocity ay may equivalent value sa galing sa position time graph mo. Okay? Okay, sige. Let's proceed. Sige, I'll just go back to D and E later on pag meron na tayong velocity and acceleration. Okay, since we're done with the different graph trends and the different implications on a distance time graph, let's proceed with a velocity time graph. Now, what's the difference between a position time graph and a velocity time graph? Because commonly, na-interchange that in terms of implications and definitions once you see them in a graph, specifically if you're not looking properly on the labels that you have between these two graphs. What do you mean by this? So let's look at the difference between them. As you can see, medyo hindi nagkakala yung difference nila because their x-axis are the same, the time is the same. However, in the y-axis, in terms of their label, the position time graph shows you that there's a distance there in the y or a displacement, while for the y-axis of a velocity time graph, it's velocity. However, as I've mentioned, their graphs look similarly the same because of the different trends. Kasi almost the same yung maglalabas na trend sa kanila, pero iba yung definition or implication noon. For this one, you can observe that it's moving forward or moving at a constant velocity. But for this one, can we say that this is moving at a constant velocity? Definitely not. So we're going to use the moving man as the PHET simulation as to check what are the different implications of the different graph trends that we'll be seeing. Okay, so I hope you were able to read naman in terms of what do you call this, the reading materials that we gave you, kasi nandun na yung definitions and the different graph trends. This is just to show you that the graph trends actually has a different implications. Okay, for this one, horizontal line, same pa rin siya, rising from left to right, falling from left to right, and then we're going to look for the slope. But if you were already reading, the slope of velocity time graph is your acceleration. So we're going to look into these three things: horizontal line, rising from left to right, and then falling from left to right, using our what do you call this? Using our PHET simulation. Okay? So, yung simulan muna natin sa horizontal line. Okay? In terms of horizontal line, if you write here negative, 4 meter per second, you can observe that if I write 4 here, it means that this is in constant velocity. Okay? So if I write 4 here, you can observe that the graph in the position time graph is rising from left to right because it's a constant velocity. Pero ano mo observe natin sa graph ng velocity time graph? Pag meron tayong horizontal line sa velocity time graph, it means that it is undergoing constant velocity. Pero pag kinumpare natin siya sa velocity time graph na straight line, what does it mean? Horizontal line. Dito sa position time graph, if you have a horizontal line, it means that it is not moving. However, for velocity time graph, if you have a horizontal line, not in the x-axis, not staying in the zero, in the zero value, it means that the value is still moving, or the object is still moving at a constant velocity. So I hope this one is clear. Okay, that's the main difference between a horizontal line of a position time graph and a horizontal line of a velocity time graph. Okay? Sige, ibalik natin yung tao. Nasaan na kaya siya? Okay, balik lang natin yung tao. Ayan. So, ulitin ko lang, if you try to observe, here, I stop the person. Here, it's a horizontal line. So, this one is not moving. Pero dito, since the horizontal line is at the zero, it means that there's also no value. Pero pag nilagyan ko siya ng constant value na 2 meter per second, observe natin yung magiging graph ha, without looking at the green one kasi that's acceleration. Ayan. You can observe that this is rising kasi there's movement already here. It's a it's a horizontal line. That's why it's in constant velocity. So, a line that is horizontal or horizontal line in a velocity time graph means a constant velocity. So, let's hide this. Let's reset everything again. Tingnan naman natin yung rising from left to right and then falling from left to right. Gamitin natin ito. So, if you have a value of 1 meter per second squared, which is constant in terms of acceleration, observe the graph of velocity. Yan. Kung sa position time graph, the value of a rising from left to right is constant velocity, sa velocity time graph naman po, ang rising from left to right is constant acceleration. Alright? So, you can see there na constant yung magiging acceleration kasi rising from left to right siya. Ibalik lang natin yung tao. Nasaan na kaya siya? Ayan, nandyan na siya. So, let me write here negative 2 meter per second squared. Tingnan naman natin yung magiging graph if it's falling from left to right. Tanggalin natin yung... Ayan. So, if it's falling from left to right, definitely it's in the opposite direction or slowing down or decelerating. So, this one is constant deceleration. Or in some cases, they call it constant acceleration as long as you still have, you write the what do you call this, the sign, kasi decelerating nga siya or slowing down in that case. Okay? So again, do not look at yung pagbiglaan na pag-stop niya. You can see here, this is constant acceleration, while this one is constant deceleration. Pag tinangnan po natin yung graph na meron tayo right now, you can observe that in terms of the graph of a position time graph, ito na yung sinasabi ko kaninang babalikan natin. since it's exponential, you can observe that the line looks parabolic. This is constant acceleration. Pero pag straight line siya na rising from left to right, constant velocity. Ito naman, this is falling down. So this is constant deceleration. And it agrees with the velocity time graph that we have right now. So let me just go back to this one. Balikan natin to. Ayan. Can you see this one? This one is constant acceleration. Well, this one is constant deceleration. Yeah. So, you can also show in terms of acceleration and deceleration as a position time graph. So, meron din siyang parang ganun na graph trend. Ayan. So, going back, here, you can observe that you have four graphs here, or four graph trends that we can identify based on the simulation that we have. We can just say that horizontal line shows that there's constant velocity. Rising from left to right is constant acceleration. Falling from left to right is constant deceleration. Pag bumaba man na siya sa zero, it means that it's still constant deceleration to rest kasi nag-stop siya dito, and then constant acceleration in the opposite direction. Again, as I mentioned, pwede siyang tawagin na acceleration, pero para mas specific tayo, we'll call it deceleration na lang. Alright? Sige. So, these are the different graph trends that we have. What I'm going to show you is yung same dito. We're going to transform from a position time graph in terms of velocity time graph and acceleration time graph. Alright, what I'm going to show you is a simple activity to show the different graph trends of a position time graph. Tapos titingnan natin how it looks like as a velocity time graph. Okay, so we're going to use first our knowledge before we proceed with the actual na simulation kung tama talaga yung dinidiscuss natin. So let's try to have a DT graph. Sabihin natin you have a distance time graph, assuming that this one is straight. Okay, so sabihin natin na the graph went from this one, so nagkaroon ng constant velocity, nag-rest, constant velocity, nag-rest, tapos nagkaroon ng tawag mo dito, constant acceleration, nag-rest, and then nagkaroon ng constant deceleration. So, assuming that my drawing is very, very beautiful and straight, we can divide this into different categories or segments. Okay, para mas madali natin siyang i-draw in terms of a velocity time graph. So, you can observe it's divided into different line segments A, B, C, D, E, F, G, and then H. Okay? Pag tinanong ko sa inyo, how many times did the car went to rest? So, hanapin natin yung mga straight lines. B, E, and then G. So, ibig sabihin, 3 times. How many times did the car went constant or experienced constant velocity in the positive direction? A, C, A and C. So, 2 times. Yan yung mga segment na meron kang constant na velocity. Halimbawa, constant velocity naman, sir, in the negative direction. D. Isa lang naman yung pababa sa kanya. So, 1 time only. Okay? Constant acceleration is in the positive direction, or constant acceleration positive is segment F. Constant deceleration is segment H. So, I hope by this time you understand now the implications just by looking at the different graph trends that you can see right now. Actually, pwede nating i-show yung segments natin as a VT graph. Okay? Pwede natin siyang i-show as a VT graph. Constant velocity, if this is A, B, sige, cut natin ha. B, C, D, E, F, G, and then H. Titingnan natin. Sige. A, B, C, D, E, F, G, and then H. A, B, C, D, F, G, H. Alright. So, you can have there, for letter A, meron kang constant na velocity in the positive direction. So, ang constant velocity naman sa positive ay a straight line lang or horizontal line Next, nag-rest sa B. So, ano yung same niya dito sa B? Nasa 0. Next, constant velocity in the positive direction, mas mataas siya compared. So, itaas-taas natin. Constant velocity. Letter D, it's constant velocity in the opposite direction. So, negative. Kasi pababa. So, lagay natin siya sa negative. Letter E is rest. Okay, letter E is rest. Letter F is constant acceleration. So, we can just write from 0. Ayan siya. Again. Ayan. And then, letter G is rest. And then, constant deceleration. So, nandito siya. Alright. So, you can observe, pwede nating ma-represent ang distance time graph sa velocity or as a velocity time graph. Tingnan natin kung tama yung magiging drawing natin dito. So, tingnan natin yung simulation. Hopefully, hindi ako mapahiya. So, sabihin natin meron tayong 3 meter per second. Sige. Stop. Let's play. Ayan. So, stop natin yung 3 meter per second. Gawin naman natin 0. Kasi nag-rest. Dapat daw siya. Alright. And then, tumaas ng nag-rise na naman siya. Okay. 1 meter per second. And then, constant velocity na opposite. Negative 2. Alright. And then, gawin natin 0. Chine-check ko lang yung ginagawa natin kanina kung tama. 0. And then, nagkaroon ng acceleration. So, gamitin natin yung acceleration na 2 meter per second squared. Oh, okay. And then, 0. Just hide this again. 0. Kasi nag-rest daw. And then, constant na deceleration, which is negative 2. Let's see. Let's check. Ayan. Alright. So, if you can observe, palitin ko lang to ha. If you can observe the graph that I made in a distance time graph, which is this one, it's just the same. Tingnan nyo. Sa F, this is A, B, C, D, E, F, G, and then H. And then, in your velocity time graph, observe, A, B, C, D, E, F, G, and then H. Yung acceleration, din naman natin titingnan yan. Ito lang dalawa. So, it still agrees with the graph that I made you, except for this one, nasa baba pala dapat ito kasi it's a lower value. I assumed na mas mataas siya. Pero you can see, it's still the same because you can represent a distance time graph in terms of a velocity time graph. Okay, so I hope this one is clear. If you have any questions, you know how to approach your different teachers. But hopefully the graph trends help you in identifying first the movement of any object before solving or checking the numerical or the quantity or bago siya ma-quantify. Okay? Thank you. Bye!